Hello wonderful person, this is Anton, and today we're going to be talking about a mysterious discovery that does not involve black holes. So I'm not going to be showing this anymore. And instead we'll show you this, the beautiful illustration created by Harvard University that shows the object of today's topic. Today we're going to be talking about the so-called Geminga Pulsar that you can see right here. This is an actual picture taken in, as you can see, X-ray and infrared light. And a discovery that was recently made and announced by NASA that helps us resolve a mystery of antimatter. Let's talk about this and welcome to What the Math. Now this beautiful pulsar is one of the few pulsars out there that has an actual name, Geminga. It technically refers to the idea of this being a Gemini pulsar and being a gamma ray source, so that's why it's Geminga. But at the same time, apparently when it was named, the scientists used a kind of a play on words from the Sicilian Geminga, which means it's not there. And it might not make sense right away why it's called It's Not There, but it has something to do with the mystery of 1972 when the unusual gamma ray source was discovered. So back in 1972, the scientists discovered this unusual gamma ray source that seemed to have been coming from something invisible that they couldn't really see, mostly because the technology was just not there yet. And it took about 10 years to finally discover that it was coming from an empty point of space approximately 800 light years away from us that also seemed to have this unusual repetition approximately every 200 milliseconds. So in other words, it was most certainly some sort of a neutron star or a pulsar. And over the years this became one of the most well-studied pulsars, and we literally looked at it for about 10 years straight to discover something really unusual. It basically created a kind of a faint halo or almost like an afterglow that can be visible if you look at it for very long time. And after looking at it for 10 years, the scientists were able to establish that this pulsar forms this humongous cloud in the night skies from which various gamma rays and other high energy particles come. But more specifically, it also seems to be a very unusual source of antimatter. And before I tell you more, let me actually tell you a little bit more about antimatter so that we're all on the same page, and at the same time explain why it's a bit of a mystery. In very high energy environments, we expect there to be quite a lot of matter and antimatter produced at all times. Actually, it's technically produced everywhere. Even your body and, well, I guess my body right now produces antimatter without us knowing about it. More specifically, well, for example, you may have heard the story of bananas being somewhat radioactive and producing enough radiation to sometimes trigger actual detectors in, for example, airports. This radioactivity comes from the specific isotope of potassium that's known as potassium-40. And our body has quite a lot of potassium-40 on the inside, and every single second, around 4,000 or more specifically 4,400 atoms of potassium decay and become a different material. Now, this is beyond the scope of this video, but in a sense this produces radiation, and once in a while, about 0.001% of the time, when the potassium decays into the other element, it releases what's known as a positron, or the antimatter equivalent of an electron. So in other words, when there is a lot of energy, there's also a lot of antimatter. And this type of antimatter is actually really important in even modern science, because for example, the positron emission tomography, the so-called PET scan, is something that depends on positrons. And although instead of potassium, normally the isotope of fluoride is used for this, the PET scan is something that's really important in various medical services today. But anyway, that's beyond the scope again, but get back to this whole antimatter and of course neutron star mystery. So the scientists living in the International Space Station for many years knew that there was an unusual amount of antimatter coming from somewhere. It was detected by various different sensors, and well, it doesn't really pose too much of a threat, but it's just too much. There was no accepted explanation for where this antimatter was coming from. For the most part, all of these positrons were stuck inside the magnetosphere and were sort of circulating around the planet, but in terms of the amount, it was never explained what truly generated them. And once we started looking around, we discovered a few sources that could be potential origins of this mysterious but unexplained antimatter. And it just so happens that the recent study and recent discoveries confirmed our initial speculations that pulsars are probably the source, and more specifically this right here. By using Fermi telescope and by looking at Geminga Pulsar for practically 10 years, the scientists discovered that this huge halo was very likely the source of about 20% of all of the antimatter striking our planet. In other words, this halo that's generated here, these gamma rays and these really high energy particles, are also creating a lot of positrons that are then striking our planet and are getting stuck inside the magnetosphere. And what's more is that the size of this object is humongous. It's actually big enough for us to technically be able to see it if we were able to perceive these high energies. They compare it to the size of the constellation known as Big Dipper, which is very easily visible in the night skies, but because this is gamma rays and because it's technically something we're not able to perceive without special equipment, it would be impossible to see this pulsar in any other frequency, which is why it's once again known as nothing there. So this is a very interesting pulsar. It's actually one of the biggest mysteries out there, and what's noticeable about this is its shape and its formation. This wasn't initially understood very well, but now we actually get it. We kind of understand what it's doing and what's happening. This pulsar is moving across our galaxy much faster than other stars, and because of this, it's sort of creating this unusual shape with the astrophysical jets producing these very beautiful formations, and then it also has this unusual tail that eventually forms these very beautiful but also these extremely long trails, I guess in some sense similar to a comet, except that this is not particles, this is actual extremely high energy radiation that then creates gamma rays and antimatter. And in a nutshell, this illustration from NASA explains it pretty well on how these gamma rays and other high energy particles are generated. So when an electron from the pulsar strikes the starlight from a typical star somewhere in the vicinity, it essentially generates the gamma ray here, but also at the same time has a chance to generate antimatter. And all of this eventually makes its way to Earth. This is of course after about 800 years, because this pulsar is 800 light years away from us, and then strikes our planet. So all of this radiation and all of this antimatter is very likely being created by various pulsars around our galaxy, such as this other example right here that you can see on the screen, known as B03555. So all of these pulsars generate so much energy and pointed directly at our planet that with time ends up being a huge amount of antimatter that then collects in our magnetosphere. And on top of that, we also think that this pulsar might be responsible for the unusual location around our sun known as the local bubble. Now this is just a location where it's slightly less in terms of density, there's basically less material here compared to other locations nearby. And we think that this was generated by an extremely large supernova, which might have been the supernova from the Geminga Pulsar. This we think happened approximately 300,000 years ago and might have been powerful enough to generate this low density environment that otherwise has no other explanation. And so we've discovered quite a lot about pulsars and about Geminga specifically in the last few years, and most importantly we now understand that not only do these objects glow in gamma ray light, they also produce a really large glow in antimatter. So these are the sources of most antimatter around our planet, and now we can finally start using this knowledge to discover something practical. But anyway, on that note, thank you for watching. Hopefully now you know a little bit more about Geminga and what it's in some sense doing to our planet, and hopefully now you understand a little bit more about antimatter and pulsars in general. On that note, come back tomorrow to learn something you may have not known before. Thank you for watching, subscribe if you still haven't, and share this with someone who loves learning about sciences and space. I'll see you tomorrow. Consider supporting this channel on Patreon because it does help me quite a lot. Space out, and as always, bye bye.